Hello everyone. My name is Bonet Timonton and I am a BS IT student from Davao Oriental State University. Now, in this tutorial, we will discuss about the stacks and queues. So, what are stacks and queues? Stacks and queues are the fundamental data structure used in computer science. So, a stacks, a stack, meaning of stack is a stack operation on a last in, first out, the LIFO principle. Now, this means that the last element added at the stack is the first one to remove. Now, think of a real-world example including undo mechanisms and software and browser history navigation. So, kana. And also think of a stack of let's say a plate. So as you can see here, the una makuha ang nasa taas, dili ang sa baba. Yes, tama. So now the queue is, a queue operates on a first in, first out, which is the FIFO principle. This element added, the first element added to the queue is the first one to be removed. Commonly used cases include scheduling task, operating system, and handling request in Java server. So now think of a real world example. The what do you call that? The line of in a line there are a lot of people. The first in line, the person who has the siya ang una makakuha og ticket, and then siya ang una pod makalakaw. So that is the example of queue. So now na nakoy daan na code diri for last time consumption para pod last time makakuan. Now the key operation in this code is the push and add an element to the top of the stack. This operate has a time complexity of 0 to 1 as it involves simple index manipulation. Now the pop. The pop removes and return the top element. This is also has a time complexity of 1 of 0 or 1, I think. Yes. At is resolved simple index manipulation. I know. Yes, ganun. Next is the peak. The peak returns the top element without removing it, maintaining 0 or 1 complexity. The is empty. Now the is empty checks if the stack is empty with 0 or 1 complexity. So let's dive into the R code. Ang gibuhat na to code. These are the class array stack, and then it has private int max size. The maximum kaya purpose is to maximum size of the stack. Next is the private int array stack array. The purpose is to hold the stack element. Next is the private int top. Now the purpose of this is to track the top of the stack. Next, after this, kuha na to, natay constructor to initialize stack with a given size, which is kaning public array stack int size, and then max size equals to size, stack array equals to new int, and then max size. Now, this stack array equals to new int size. It initializes array to hold stack the elements. And this the top equals to -1. The purpose is to set top to -1 to if what we call that empty stack. Next, we have here the public void push int in kani siya, kaning block of code kani response purpose ani is to push push operation and adds an element to the top of the stack. Now, the if else statement, if else ang purpose ani is to ensure there's space. Kaning top is max minus 1, and then next is the stack array increment top equals value. Now the purpose of this is to increment top and insert value. Then the system that will push value. Next, we have the we have the pop operation. Now, in pop operation that has the purpose of remove and return the top element of the stack. We have also if and else statement, and then the purpose of this if is to ensure stack isn't empty. Now, in int value is equals to stack array, the top decrement. The purpose of this is to return a value and decrement top. And next, we have public int peak. Now, in peak operation, it returns the top element without removing it. And we have the return stack array top. This purpose over here is to return the top value. Next, we have the is empty operation. Now, this purpose over here is to check if the stack is empty. Now, to return top is equals to, and then -1. Purpose of this is to stack is empty if top is we call that -2, -1. Now, in segment 2, the stack implementation using linked list. This class node, the int data and node next. And kaning int data, purpose ani is to this data stored in the node, while the node next semicolon has the pointer to the next node. Now we have the constructor, the node int data, and then we have this that data is equals to data. Now the purpose of this is the constructor to initialize node with data. Next, we have the class link stacks. It has the private node top semicolon, and then the purpose of this is it has the point to the top node in the stacks. And next, we have public void push. Kani sila. Kaning ni. This is a push operation that adds a new node to the top of the stack. And then kaning line over here, kaning line of code, the purpose of this is to create a new node. Ani pod, kaning new node that next is equals to top. The purpose of this is to point new node current top. And then next is we have the pop operation. Kaning public int until kani. Kani siya is the pop operation. Now, kani sila it removes the return and top node of the stacks. Public int top. Pop. Then kani siya f. It ensures the stack isn't empty. And the int value, the store data of the top node. And we have here the top is equals to top.next. And purpose of this to move top pointer to the next node. Next, we have the peak operation. Sorry. We have the peak operation. Kani sila. Public int peak. Now, the purpose of this is to return the top node's data without removing it. Now, if else, we have the return top data. The purpose of this is, of course, to return the top node to data. Next, we have the isEmpty operation. Now, kaning public boolean is the purpose of this is to check if the stacks is empty. Now, the purpose of this return top is equals to null. Stack is empty if top is null. Next, we have the segment 3, the queue implementation using array. Now, in this private int max size, the maximum of the queue, and then this private int queue array, purpose of this is the array to hold queue elements. And in front point, purpose is to point to the front of the queue. We have int rare. This purpose over purpose here point to the rear of the queue. Next is the number item. This is number of items in the queue. Next, we have the call this the constructor to initialize a queue with a given size. Ano sila? We have the queue array is equals to new int max size, and then purpose ni is to initialize the queue array. Then front 0, start from the front at position 0. Rares -1, start the rare at -1. Queue is empty. Number items initially queue is empty. Now we have the operation, what we call the unique operation. Kani sila. It adds an element to the rear of the queue. Monitoring purpose is to adds an element. If is to ensure the space, and then Inner if is to handle a circular queue wrapping. Next, we have the queue array. Now, purpose of this kani is to insert value at to insert value and increment rare. Next is the number items. The increment items count. Purpose ani is to increment item count. Now we have the DQ operation. Anisa. Kani we have the method DQ operation. Ang purpose sa DQ operation is to remove and return and front element of the DQ. Of the queue. So what today if ensure queue isn't empty, and then intent kani purpose ani is to get the front value and increment front. Kaning inner if purpose ani is to handle circular queue wrapping. And then we have the number items, the decrement item count. Purpose ana is to decrement item counts. And now we have the pick operation. Purpose ani kaninga line no lack of code is to return the front element without removing it. And then kaning if statement ensuring not queue isn't empty, and then it has a return array front, return the front value. And then next we have the is empty operation. This purpose ani is to check if the queue is empty. We have the return, the queue isn't empty. Purpose ani is queue is empty if no items. Now, next is the segment number 4, the queue implementation using linked list. Ang kani sila linked list, queue implementation using linked list. So in data purpose of this is to store data in the node. Yan. Kaning node queue, that node queue next is the purpose and is the pointer to the next node. We also have the constructor to initialize node with data, kaning node queue, and then int data. And then this that data is equals to data. Ano siyang constructor. Next we have the class linked list queue. And then the private node queue front. Purpose of this, the point to the front node of the queue. Next is the private node where. The purpose of this is to point to the where node of the queue. Next we have the unique operation. In queue operation pala. Kani. So, ang purpose of this sila is to add a new node to the where of the queue. Kaning we have the node queue equals to new node, and the new node queue value. Purpose is to create a new node. And we also have the where.next equals to new node. These purpose are link current where to the new node. And then we have where equals to new node. Purpose is to update where pointer. Next we have the if kaning line, purpose is if Q was empty, and then is it set niya from to the front, set niya from to set niya from front to the new node. Next, we have the DQ operation. Kanina sila. It purpose is to remove and return the front node of the queue. Kaning if statement to ensure isn't empty, and then int value to get data from the front node. We have front equals to front.next. Purpose ani is to move front pointer to the next node. We also have inner f statement. Purpose ani is ang queue is now empty, and then reset rare. Yan. Next, we have the again pick operation. Kani. Purpose aning pick operation is to return the front node data without removing it. We also have return front data. Purpose ani is to return front node data. Next, we have the SMT operation. Same process pa din. Check if Q is empty. You have to return type na return na pod Q is empty in front and in front is null if front is null. Now lastly, we have the main class, the main method, the main class to test stacks and queues implementation. Kani siya. Kani sila is the test array stacks. Sila operation sa array stacks. We also have the linked list operation stacks, test stacks, linked list task, stacks. We also have the array queue, test array queue, muna sila. And then we also have the test linked list queue, kani. And then na. So, muna sila, muna sa finish code ni. And then paranon natin run as Java. So what we have here is the testing array stacks, the push 10, push 20, push 30, then top of stack 30, top pop 30, and then pop 20. In the stack empty, then it print false. So kuan siya false siya. And then the linked list stacks, we have push 100, 200, and 300, and then it has top of stack 300, pop 300, and now it is stack is empty, false, of course. Now we have testing array in array queue. We have the in queue 1, 2, and of course 3. We have front of queue 1, and then we have also DQ 2, DQ 1 and 2, and is Q empty? Of course, false. Testing linked list queue. What is it? Testing linked list queue. And then in queued, we have 10, 20, 30. Next, we have front of queue with 10. We have the value of 10. And then we have 2 DQ with the value of 10 and 20. Now, the question is, Q is empty? Of course, false. So, That's all for the discussion about the queues and stacks. And then, as you can see here, mga code. And then, so, I believe that's all for the video. Um, Hope you like it, and bye. See you again for the next tutorial. Just yeah, stay tuned. Bye bye.